All right, today we have section 7.6, which is solving inequalities, solving two-step inequalities. Okay, so let's review here. Here's our review. I want you to solve and graph the following. All right, so the first one is x plus 3 is greater than 7. Okay, so I'd subtract 3 from both sides. I would get x is greater than 4. Okay, so then I just draw my number line. 0, 1, 2, 3, 4. X is greater than 4. Remember, if it's greater than or less than, we have an open circle. If it's greater than or equal to or less than or equal to, we have a closed circle. Okay, so this one is open, so we'd have an open circle. 5, 6, 7. We need x to be bigger than 4. So our arrow is going to go this way, and this would be how we would graph that. Okay, because in this case it is not equal to. It doesn't have that line underneath it. Let's try another one. Negative 14 is less than or equal to negative 2x. Okay, I need to divide both sides by a negative 2. And I would get x, and on this side I'd get a positive 7. Here's the deal. Whenever you divide or multiply, I know we've talked about this, but it probably slipped your brain. Whenever you divide or multiply by a negative number, we need to switch our inequality. Okay, so instead of it being less than or equal to, now we are greater than or equal to. So x is, well, kind of, we'd say x is less than or equal to 7. Okay, so now I draw this out. It's positive 7, so I'm going over here. Guys, make sure this gets in your notebook because this is so very important. Miss Westrom even came and talked to me this year and said make sure they know when they're multiplying and dividing by a negative number. That means this part right here. Doesn't mean that your answer is negative, but if you ever multiply or divide by a negative answer right here, you got to flip your inequality sign. Okay, so 1, 2, 3, 4, 5, 6, 7. Now we'll go a little bit farther. 8, 9. Okay. So we always start with the variable when we're talking about it, okay? X is less than or equal to 7. Okay, so I know it's going to be closed circle because it's equal to 7. And x is less than 7, so that means that my arrow is going to go to the left. Remember I taught you that cute little chant, less than left, greater than right. So LL, less than left, greater than right. That's an easy way to remember that. Okay, so now let's do some new stuff here. I suppose we don't really need to write new. Okay, first one, we have to solve and graph. So that means you need to make sure that you're leaving room to graph all of these on your homework. Okay, so the first one we're going to do is 5a minus 9 is greater than 11. Okay, so again I would just add 9. So I would get 20 is greater, well, you guys get the point. Okay, 5a is greater than 20. So then I need to divide both sides by 5, divide by 5, okay, and I'm dividing by a positive number, so that means I don't need to switch the sign. So I would get a is greater than 4. Okay, now I can do my little graphing. 0, 1, 2, 3, 4, 5. Don't get lazy on this, you guys. Just make a nice little number line Make sure I can tell if it's open or if it's closed, okay? And A is greater than, so that means our arrow is going to go to the right. And by the way, that only works greater than to the right, less than to the left, if our our variable is on the left side, if we start with our variable when we're reading across. Okay, so there we go for that one. Number 2. Negative 10 is greater than or equal to 1/2 x minus 6. Okay, so let's add 6. Add 6. So I would have a negative 4 is greater than or equal to 1/2 x. Okay, so I need to divide both sides by 1/2. Divide by 1/2. I'm going to move us up here. So if I have negative, oops, I better not take up our space over there. If I have a negative 4 divided by 1/2, it's the same as saying negative 4 times 2. So I would get a negative 8. Okay, so I've got a negative 8 over here is greater than or equal to x. Okay, and yes, this is a negative number here, but it doesn't matter because this is positive, this is positive, and this is positive. Well, then that's adding anyway, so we wouldn't do it for adding. Okay, so yes, it is a negative 8, but we don't flip our sign because we didn't divide or multiply by a negative 8. All right, there we go. Now let's graph it. Negative some point 0 over here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Okay, so is it going to be an open or closed circle? That's always the first question we'll ask ourselves. Is it open or closed? Well, this one's going to be closed because it's equal to negative 8. And x is less than or equal to a negative 8. So that means our arrow is going to go this way. Okay, and how you can do that, you can say, is negative 8 greater than or equal to 0? Negative 8 is bigger or equal to 0? No, that doesn't work. Okay, so we know we're not going to go to the right. We're going to have to go to the left on that one. Okay, now number 3. This is the same. We have to graph and solve. Negative 3 says 7x plus 2x is greater than or equal to 21 minus 3. Okay, so 21 minus 3. If I have 21, I take away 3, I'd get 18. Positive 18 is there. And 7x plus 2x, I'd get 9x. Oh, well, this will be a nice one. Divided by 9, divide by 9, and I would get x is greater than or equal to 2. Okay, let's graph it out. 0, 1, 2, 3, 4. 2 is going to be a closed circle because it is equal to 2, so it could be 2. And x is bigger, greater than or equal to, greater than to the right. So our arrow goes that way, to the right. Okay, now we have a new set of directions that just say solve. That means we don't have to do any graphing, we just have to solve it. So for number 4, we're going to do negative 2m plus 4 is less than or equal to 34. Okay, so I'm going to subtract 4 from both sides. I'd be left with 30 on the right side, and I would be left with a negative 2m on the left side. So if I divide by a negative 2, divide by a negative 2, this is where bells should be going off in your head. Because we cannot, or if we divide by a negative number, we have to flip our sign. So you see I flip my sign because of these negative signs here and our dividing sign. If we were dividing or multiplying by a negative number, we have to flip that inequality. Okay, so I'd be left with m on the left side. 30 divided by a negative 2, can't really see that very well, would be a negative 15. Okay, we do not have to graph this. So this would be our answer right here. And how you can check your work for this one is we can do negative 2 times a negative 15 plus 4 is less than or equal to 34. Let's make sure this works. Okay, so I'd get 30 plus 4 is less than or equal to 34. I'd get 34 is less than or equal to 34. It is equal to, yep, checks out. Okay, so we can always check that out and make sure it works. Let's try another one. Number 5 says 6 minus x is greater than 3. So I'm going to, this isn't going to be fun. We'll do it. Minus 6 minus 6. So I'd get negative x. Please do not forget. We take the sign that's in front of it. If it's positive, we don't worry about it. Okay? But if it's negative, we have to bring down that negative sign if it's right in front of the x. Yes, I know that is a subtraction sign, but really in the long scheme of things, the long term, that is a negative sign. So we have to take it if it's right in front of it. Is greater than 3. I have $3. I owe you $6. I'll pay you by $3 now, but I still owe you $3. Okay, I cannot have a negative left here, so I need to divide both sides by -1. Divide both sides by -1, and I would get x. Oh, we're dividing by a negative number. Don't forget to switch. I almost forgot to switch. X is less than a positive 3 because a negative divided by a negative makes a positive. Okay, so we don't have to graph that one. That's just our answer. But make sure you flip that if we multiply or divide by a negative number. Multiplying or dividing by a negative number, we got to switch our inequality. Okay, let's do number 6, which is our last example like this. And we'll do one word problem here pretty quick. We've got 8 3/10 is less than negative 5/10 b minus 2 7/10. All right, let's add 2 7/10. Add 2 7/10. I'd get a 10. 8, 9, 10, 11. Bring down my decimal. We got to line up those decimals when we're adding and subtracting. Decimals. Anyways, okay. So now I'm left with 11 is less than negative 5/10 b. Divide both sides by negative 5/10. Divide by a negative 5/10. Okay, so I got to flip my sign because I'm dividing by a negative. And I would get b on that side. 11 divided by 5/10. Move it over 1. Move it over 1. So really what I'm doing is 110 divided by 5, sorry. 110 divided by 5. Okay, I can get rid of this 0 here too. So it looks much better. That looks much better. Here we go. 2 times it will go into 11 minus 10. Okay, 2 times, 22. There we go. B is less than 22. Or 22 is greater than B. But I think that's kind of a little bit hard to wrap my head around sometimes. So I just like saying B is less than 22. Okay, now we have a little word problem to solve. I would really appreciate you guys if you tried the word problems. We're never going to get better at word problems if we don't try to figure them out. Okay, so we have our friend Dale here. He has $25 to spend at the carnival. If the admission is $4 to get into the carnival and the rides are $1.50 each, what is the greatest number of rides Dale can go on? Okay, so I know $4 is not going to change. He's going to walk into that carnival and he has to pay $4. That $4 is not going to go up. That $4 is not going to go down. So that's our constant right there. I have to pay $4 to even walk in to the carnival. And then on top of that, I have to pay $1.50 for every ride I go on. Okay, so if you think of what's going to change, my price to get in is not going to change. What's going to change is my price to go on the rides. Because I could go on 5 rides, I could go on 10 rides. I have to figure out how many rides I can go on. Okay, and since this is going to be an inequality, it says greatest number of rides he can go on. So he could spend all of his $25, right? So it could be equal to 25. Or it could be less than $25, but it could never be more than $25 because I could never spend $26 because I only have $25. So we need to make sure that whatever he's spending is less than or equal to $25 because that's all he's got. All right, now let's solve this. So if I subtracted 4 from both sides, I would get 1 and 5/10 r is less than or equal to 21. Okay, now I need to divide both sides by 1 and 5/10. Okay, so I have 21 divided by 1 and 5/10. Could I have put my 0 there? Yes. But does it really matter if it's there or not? No. Okay, so I'm going to make that into a 15, and my 21 becomes a 210. I have to move the outside and the inside the same amount to make my outside a whole number. 15 goes into 21 once. If I take 15 away, I would get 6. Bring down my 0. Well, I know 2 15s is 30. 2 30s are 60. Okay, so I've got 4 15s that will go into 60. So I would get R could be less than or equal to 14 rides. So that means he could go on 14 rides. He could go on 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Or no rides. But he's going to have to spend at least $4 to get in. Okay? So he can go on 14 rides. That's the biggest number, but he could go on less too if he didn't want to spend all of his money in one spot. All right, now this is the last section that we are going to do of this chapter. There is a section 7.8, but we are going to skip that one. So after you finish up this, you will have a review. Then the next day you will have a test. So please make sure if you have any questions, you get into me before the test, because the test will be 2 days away from whenever you're listening to this. All right, thank you for watching.